a machine designed to pick or lift a load using wire rope. They provide a high lifting height and a good working radius while taking up very little area on the job site. This engineering marvel is known as the tower crane. Typical components of a tower crane include a square concrete base and a tower made of square steel lattice cross-sections of 4x4 to 8x8 feet. Tower crane horizontal jib lengths range from 100 to 300 feet. They also possess a trolley on the long end of the jib to lift and lower the load, as well as a counterweight on the short end of the jib to offset it. Tower crane components also include a mast section length of 10 to 20 feet with pendant cables to support the jib. Another important element of the crane is the use of electric power. Tower cranes use electricity to operate with alternating current motors. Lastly, the cab provides the operator with the essential controls to run the crane. Top slewing cranes allow only the long horizontal jib, tower top, and operator cab to rotate, and the tower cranes have the ability to raise themselves by adding tower sections. They have a special hydraulically operated section termed the telescopic climbing cage or climbing frame. Sections are inserted within the cage to add height. Creation of a top slewing tower crane may require the assistance of other equipment, commonly a large mobile crane. Removal may also be accomplished with another tower or mobile crane. A vertical limit known as the maximum freestanding height is how high fixed base cranes can safely rise above their base. Typically 200 feet for average-sized top slewing cranes and up to 400 feet for the larger cranes. Tower cranes are engineered to withstand high wind speeds. However, winds may affect the stability and operation of the crane through forces imposed on the profile and structure of the crane or on the load being lifted. The jib made of lattice sections allows the air to flow through the structure. Counterweights and contractor nameplates create wind forces on the jib.
If wind gusts get in excess of 45 miles an hour, they'll actually shut the crane down, not remove the gears, but disengage the gears so that it'll spin like a wind vane if it has to.
Selecting a tower crane for a project can be a challenging task, particularly if the project is complex or has a large footprint. The crane must have the capability to meet the required production demands of the project schedule, such as concrete formwork and rebar placement. Quite often, two cranes will have to operate in a shared work zone to meet lifting demands. A crane having a higher horsepower motor can achieve faster operating speeds. When considering the production capability of a crane for duty cycle work, hoist line speed and motor size can be very important. This is especially true for high-rise construction, where travel time of the hook between loading and unloading areas can be the most significant part of the crane's cycle time.
If you got somebody on the ground that knows what they're doing and the crane operator's good at what he does, he can swing it down to the ground, pick something up, and have it up to the deck within a minute too. So a lot of it's based on experience. If there's any breeze that day, that'll slow things down just because the block on the end of that wire will start swaying a lot more, and you don't want that going everywhere.
Hoist cable configuration is another factor affecting lifting speed. Tower cranes can usually be rigged with 2-part line or a 4-part line. The 4-part line configuration provides a greater lifting capacity than a 2-part line, but has only half the vertical hoist speed of the 2-part line. Typical lifting capacities for tower cranes range from 10,000 to 90,000 pounds, but can be higher for larger cranes.
Like at the farthest reach of the jib on here, you can lift 6,800 pounds. It's got, I think, 11,000 pound capacity out there, but you're only gonna usually lift about 6,800 to 7,000 pounds.
The load must be properly attached to the crane by a rigging system. The rigger must correctly determine the weight and center of gravity of the load. The safety and efficiency of a lift depend on the working attachments or slings that secure the load to the crane hook. These attachments may be wire rope, chain, or synthetic nylon web straps. The capacity of the sling depends on its material and size, and the angle that the legs make with the load. Synthetic slings are good for use on expensive loads, highly finished parts, fragile parts, and delicate equipment. They have less of a tendency than wire rope or chain slings to crush fragile objects. Because they are flexible, they tend to mold themselves to the shape of the load, thus gripping a load securely. Synthetic slings are elastic and stretch more than wire rope or chain, better absorbing heavy shocks and cushioning loads. Tower cranes are important to the construction industry, whether constructing a tall building or a bridge pier over water. They are capable of high lifting heights and a good working radius while taking up very limited area on the job site.